Hi, so this is going to be part 5 of my AeroSense IT/OT project, and in this part I'm going to explain how I have set up the sessions, the data models, as well as the three layers, the bronze, silver, and the gold processing layers. So here I've first started by importing all the required functions, the generators, the context managers, the create engine from SQL Alchemy, the session and the session makers, and I'm also importing the base. So this is the base class that I'm importing, and I'll explain that as well. So first I'm creating an engine. So engine is what maintains the connection between the program and the database so that the data can be written. And the pool pre-ping, so I've set this to true. So basically what this does is it checks if there are any connections already available. If there are, it will be used, else new ones will be created. The pool size equal to 5, it says there will be 5 connections always available, and if more are required, that's when the max overflow come into picture, and it can have a maximum of 10 extra connections. So at any time there can be a maximum of 15 connections, and when the usage decreases, the max overflow connections will be terminated, and only the pool size 5 or the 5 connections that we have initially defined will be the ones remaining. The session factory, it uses the engine that we have defined here and creates sessions. And we have set the expire on commit flag equal to false here. So to explain this, when SQL Alchemy uh, starts a session, writes data onto the database and commits it, it basically forgets the values that it has already written into it. But if we set expire on commit equal to false, it means that SQL Alchemy will keep in memory the variables that it has just committed. So first we'll be inheriting the base metadata and we'll be creating all the tables. So this function just does one thing. It creates the table if it doesn't exist. It doesn't do anything else. So here first we are defining a session, and it will be returning a generator, and it has one output, and that's a session. And these two are to send and receive variables. These are high level functions and we won't be using these here. So this function has a yield. So this function can also be split into two. Everything that happens before the yield and that happens after a yield. So basically what this whole function does is it does the whole process of initiating a session. It writes the data, and once the session yields, the data will be committed. So if the write process is complete, it will commit, and if not, then it will be rolled back into the previous stable session. And either ways, finally the session will close. So this is how the whole session will happen. Now on to the models. So when the models have defined a base class here, and this base class will inherit everything from this bronze, this silver, and gold telemetry features. So when this base class is called, these three tables will be generated if it doesn't already exist. So in the bronze telemetry, these are all the values that will be collected from the broker. So ID is the primary key, ingested at is the time the data is being ingested in. We'll be mentioning the Kafka offset, the partition, as well as the main part is this payload here. So this will be a dictionary containing all the values that are collected from the different devices in VBots. And finally, the process to silver. This is a flag, and this basically says if the data has been processed from bronze onto the silver tables. And the same way for silver here, ID is the primary key, and the bronze ID processed at, and this processed at is the time the data is processed onto the silver table. Again, here there is a process to gold. So if the data is processed to gold, it will be a true, else it will be a false. The same thing again for the gold telemetry. So these some of these are derived variables, and I'll be explaining those later. Okay, so now since I've showed you three of my tables, I'll explain the bronze telemetry in detail. So for bronze telemetry, I have started by importing all the required functions, JSON for handling the JSON, date time, the structured log for structured logging. These are for handling the Kafka errors. This is for the pydantic validation error. And I'll also be importing these three main ones. So the models, the bronze telemetry from the models, sessions to create table and to get sessions, as well as to validate the telemetry message. So here I'm using a run equal to true method. So why I'm doing this is because I want an option to end the process gracefully. So I could use a while loop here, but all the options that comes with while loop like continue, pass, break, etc. like none of these helps to send a signal to end the process. It just ends it abruptly. So here what I'm basically doing is I'm asking this program to wait for signals. So if I do a control plus C, since I'm doing this whole process locally, it will send a signal SIGINT onto the system, and this will ask the program to start the shutdown process and to end the process gracefully. And the SIG term, it waits for the kill PID signal. So what I'm doing here is I'm making a record. It will be taking the message value, which is a dictionary, offset and partition, and if everything checks out, it'll return a bronze telemetry, and it will have the payload data as well. I'll show the final structure of the message in an Excel later. So in the main function, I'm first creating the tables if it doesn't already exist. Then first I'll be defining the consumer. So as I've said in Kafka, there are three main parts: the producer, the broker, and the consumer. The consumer will be pulling the data from the broker, and here these two are Kafka variables, and I'll explain these two variables here. So auto offset reset equal to earliest. So what this means is if the consumer is polling that particular topic or the broker for the first time, then it has to start from the first message. So that's why it's set to earliest. And if it's not the first time it's polling, then it can continue from the offset and enable auto commit equal to false. So Kafka by default, once the data has been read, it will be marked as processed. But it has an issue because if the downstream process fails anywhere, the data will be lost. So in order to make sure we commit the data properly and to make sure all the data is committed onto the database, we are setting the enable auto commit equal to false so that we have the option to manually commit every successful DB writes. So consumer subscribe basically means this is where the program starts to pull data from the Kafka. And here I've set the timeout equal to 1. Basically, it means the polling will happen every 1 second. So if the message is none, it's a continue. If the message is an error, we'll check for the error code. It can be handled in a couple of different ways. So if the error message is partition EOF, it means end of file. So it means we have done reading the whole stream. And if it's an unknown topic, it means it's not the one that we are supposed to read, and we'll be raising that using a Kafka accept error. And if the message is, if we do receive the payload, we'll be decoding it. It'll be raw bytes. So we'll be decoding it onto UTF-8, and we'll be checking the data types. If the validation is proper, we'll start with the commit part. So first we'll be creating a session. We'll be adding that record onto the bronze table. Then we'll be committing the message, and then we'll be logging extensively saying the right transaction is done. So either ways, finally we'll be closing the consumer and logging it again. So this is how I've set up the bronze consumer layer, and I'll explain the silver as well. So in the silver layer, it's the same process. I'm using the running equal to true method again. But here, instead of taking data from Kafka, I'll be taking the data from the bronze telemetry layer. And I'll be checking the telemetry message in order to check if all the data types are proper. I'll be flattening it. Basically, I'll be taking the payload dictionary and I'll be taking all the values out. I'll be flattening it. So that's how I'm getting a lot more position X, Y, Z, all these values separately. And I'll be processing the rows in batches basically. So I've set the limit to 100. So I'll be processing 100 row entries from bronze at the same time. So first I'll be selecting the bronze telemetry. If the process to silver is 0 or false, then it will be processed. So this is what happens in that particular session. And for each rows, we'll be validating it first, the payload part. Uh, then we'll be flattening it. We'll be adding it to the silver, and then we'll be flipping the true or false value in the process to silver column in the bronze table. And everything else is the same as in bronze. So this is how I've defined the silver process, and it's the same in gold as well. First, we'll be returning this data, and we'll be writing to the silver table if the row has been processed or not. So this is how I've defined the three layers in my database, and in the next video I'll explain how I'll be handling the training, testing, and inference pipelines, how I'll be handling the ML artifacts, and the inferencing part as well. Okay, thank you.